Alright, so here's the first problem. First thing we're going to look at is the domain of this function, then we'll look at the range, and then we'll algebraically go about finding the inverse. Okay, domain first. You notice there's a fraction here. Okay, so when you see the fraction, look at the denominator. We always have to worry about dividing by 0. In this case, the denominator is fixed at 10. So there's no x value that we're going to plug in that will produce a divide by 0. Right, so you don't have to actually concern yourself with the fraction in this instance. We do have a square root though. And we have to make sure we're not taking the square root of negative numbers. So one way is to just kind of intuitively say, what must x be in order for 6 minus x to never be negative? I'd say, well, okay, the blue portion here, let's see, x, if x was 10, would that be okay? Nope, 6 minus 10 produces negative. If x is 6, would that be alright? Yup. 6 minus 6 is 0, square root of 0 is 0. So 6 works, 10 doesn't. Does 5 work? Yep, 6 minus 5 is 1, we can take the square root of 1. So it turns out that everything smaller than 6 works. So our domain is going to be, so everything smaller than 6. So from negative infinity up into 6. And we want to include 6. Now you might think, well, why didn't you consider the plus 5 when you were looking at domain? Well, plus 5 wasn't part of the denominator of the fraction. It wasn't underneath the square root, so it had no effect on the domain here. Next thing we're going to look at is the range. Right, so range is all about outputs. If you physically took every number in the domain, every number in this interval, and plugged it into f of x, you would get different outputs. So we'll do a few of them. So I'm going to take some of these numbers in here and put them in for x. So 6, 5, negative 10, negative 80, negative 1000. So when you plug 6 in, so f of x, we'll make some more room. Let's do this. So when you plug 6 in, so you have the square root of 6 minus 6 over 10 plus 5. That's equal to 0 over 10 plus 5. 0 divided by 10 is 0. 0 plus 5 is 5. So, when x is 6, f of x is 5. Right? This work in the middle, that's just our process work. So let's go to 5 now. Take some of these out. Okay, so plug 5 in. Square root 6 minus 5 divided by 10 plus 5. That's the square root of 1, which is 1. So we have 1/10 plus 5. That's what 5 is 50 tenths, so 51 tenths. We'll do one more. Let's do like negative, let's see if I can, negative 75. Okay, so we got the square root of 6 minus negative 75 over 10 plus 5. Okay, that's square root of 81 over 10 plus 5. So square root of 81 is 9. 9 tenths plus 5. 9 tenths plus 50 tenths is 59 tenths. Okay. So all of these numbers that we're seeing over here, those are all numbers in our range. Right, so right now when we look at those, the smallest number that we see is 5. Right, so is there any way we can get a number over here that's smaller than 5? No, there's not. Right? There's no way we can get a number smaller than 5, because the smallest that you can make this thing is 0. Right? You can actually make that 0. So the smallest number we can get is 5. If you consider what's in that orange box, okay, that fraction there, what can it be? Well, that fraction there, can it be 0? Yep. Can that fraction be anything negative? No. Right? Here's why. Just think about the square root of 6 minus x. That's up here. What can the square root of 6 minus x be? At the smallest it can be 0, right? At the largest it can be what? Infinity. Now this notation is kind of a little awkward. But you have, think about the number set from 0 to infinity, including 0, and you're going to divide that by 10. Okay, what number set is going to be left? Right, take every number from 0 to infinity, including 0, and divide it by 10. What numbers are you dealing with? Well, 0 divided by 10 would still be 0. Well, wait, I'm still working with 0 to infinity. Now we weren't done. We still have the plus 5 to consider. So take your number set here, right? All of those outputs. Add 5 to them. What set of numbers are you working with? Well, after you add 5, you're working with 5 to infinity. So a lot of analysis here to find range. Okay? I'm not trying to give you any quick tricks. I want you to really analyze the function and consider what's happening, and is it happening in the denominator or numerator? So our range is from 5 to infinity. Okay? Range 5 to infinity. Okay, the last part of this task for this problem was to find f inverse. So we'll make some room. F of x equals the square root of 6 minus x over 10 plus 5. I want to be able to check our answer in the end, so here's a little trick I'll use. So x f of x. If we go back up to our table, we said when you plug in negative 70, well, let's go when x was 6. When x was 6, you ended up with what? We should end up with 5. Okay, so that means f of 6 equals 5. When we're all done, we're going to use this as our check. What is f inverse of 5? I want the answer to be 6. Okay, so we need to check if our inverse function is correct, the answer will be 6. So we're going to hold on to this thinking and set it aside. Alright, so process here. We got y equals square root 6 minus x over 10 plus 5. I'm going to solve for x. Subtract 5 from both sides. I have y minus 5 equals square root 6 minus x over 10. Now I'm going to multiply both sides by 10. Right. So that gives me 10 times y minus 5 equals square root 6 minus x. Still trying to isolate x. So x is underneath the square root, so we'll square both sides. Squared. Squared. So that's going to strip off the radical on the right-hand side. So right now we're dealing with 10 times y, quantity y minus 5 squared equals 6 minus x. Okay. Well, you want to isolate x, right? So I'm going to go ahead and I'm going to add x to both sides. Plus x, so I'm going to make it positive. So I have x plus this whole thing. We can simplify this. 10y minus 50 squared equals 6. I'll subtract it now, so I get x by itself. subtract that from both sides. And you have x equals 6 minus 10y minus 50 squared. Wow, that was a lot of work, right? Well, let's go ahead and let's check it. Okay, so I'm going to go to the next page. I saved this work here. So we need our final right of our inverse. So f inverse of x equals 6 minus 10. Now we're going to change y to x. So when we plug 5 in, we want to get 6. So I'm going to plug 5 in. Okay, we'll see if we get 6. So f inverse of 5 equals 6 minus 10 times 6. Sorry, 10 times 5. We're plugging in 5. 10 times 5 minus 50 squared. So that's 6 minus, well, 50 minus 50 squared. 6 minus 0 equals 6. We did it. You could check a couple more values, right? Look, we plug in 6 and we get 5. When we plug 5 into the inverse, we get back to 6. You could, find another test point to be sure. That wouldn't be a bad idea. But here is your inverse function, right there.